Hello again. This video is a continuation of section 5.5 from Math in Our World. In this video we want to continue talking about the properties of the real number system. So far we have talked about the closure property. The next property is the commutative property. And we actually have two of these. There's one for addition and one for multiplication. And you may be wondering, why do we keep focusing on addition and multiplication? Because we're going to start ignoring some of the other ones. They're not in your textbook. And that is because addition and multiplication are the two properties or the two operations for the real number system. Anything that's division or subtraction can always be written in terms of one of those other two. So for example, if I had 3 minus 4, I can really think of that as 3 plus negative 4, and then just use the property for addition to talk about that answer and some of the properties of that operation. Alright, so the commutative property. I know you've seen this one before. This is the one that justifies why we can switch the order for addition or multiplication and get the same answer. So I know that 3 plus 4 is the same as 4 plus 3 because of the commutative property. And I know that 1/2 times negative 5 is the same as negative 5 times 1/2 because of the commutative property for multiplication. Okay, how about subtraction? Is that commutative? Alright, so if it is, then explain why. If not, give a counterexample. Alright, well, let's come up with a subtraction problem. 6 minus 1. And if the commutative property holds, if it's true for subtraction, then we should be able to switch the order of those two numbers and have that be a true answer. All right, and that's not true, so subtraction is not commutative. How about division? We can do the same example, 6 divided by 1, and if division is commutative, we should be able to switch the order of those two numbers. Okay, well, this is 6. But 1 divided by 6 is 1/6, and those are not the same. So no, division is not commutative either. The associative property, this is the one that changes the grouping. You can think like association, which numbers are grouped or associated with each other. Alright, so going back to commutative. Commutative is the order which has changed. Associative is the grouping that's changed. So for example, if I add 2 plus 3 first and then add 5, I get the same answer as if I added the 3 plus the 5 first, if I grouped those, and then added the 2. Right. Now notice that the order has not changed. We still see 2 and then 3 and then 5 in that order, but it's the parentheses that have moved. And that shows new grouping. Okay, and then we can say the same thing for multiplication. Right, so 1/2 times 3, and then multiplied by 5 is the same thing as 1/2 multiplied times whatever the answer to 3 times 5 is. Same thing. Okay, how about subtraction and division? Right, so try a couple examples. How about 5 minus 4 minus 3, and let's put parentheses here. And then we want to see, is that the same as 5 minus 4 minus 3, putting parentheses there. Okay, so see what you think about that one. And then division. Let's try something with numbers that are easier to divide. So how about maybe 12 divided by 4 divided by 2. Okay, see if 12 divided by 4 first is different than if we did 4 divided by 2 first. Alright, and you may want to try a couple other examples just to see if this seems to be true all the time. Okay, here is an example of how we can use the commutative and associative properties. We often use these when doing mental math to try to make the problem easier than the way that it's written. So for example, in this first one, if I followed order of operations, I would have to do the parentheses first, 37 times 25, which is not really easy to do mentally, and then I would have to do multiplication and multiply by 4. Well, if you're looking at this, you might kind of notice 4 and 25, and usually people who are good at mental math recognize these properties and have that freedom to move the numbers around using these two properties. Right, so what I would like to do is multiply 4 and 25 first. I know that's 100, and then that would make it easier to multiply by 37. Well, how do I know I'm allowed to do that? I know because of these two properties. All right, so first thing I could do is switch the 25 and the 37. Right. And if you look at the part of the problem that I've changed, why am I allowed to do that? Well, I've switched the order of two numbers that are being multiplied, so that's the commutative property. All right, so if I'm justifying this change, I would justify that by saying, okay, I used the commutative property. All right, now this problem, this new expression, I should still do the parentheses first, so I'm still at that same difficult operation. But what I'd like to do is move the parentheses and multiply the 4 and 25 first. All right, and which property tells me that I can do that? Well, if you look at what's changed from here to here, I've moved the parentheses, I've changed the grouping. So this is the associative property. And then from there, I would just follow order of operations and work the problem as normal. Do 100, and then multiply, and that's just adding 2 zeros on the end. All right, how about the second one, 57 plus 96? Well, it doesn't really seem that it would be helpful to switch the order of these numbers, and it also doesn't seem like I can even use the associative property because I don't have 3 numbers in order to be able to regroup. All right, but here's a second option for what I can do. I can break down the numbers and put them back together in a different way, and I can rearrange the order or parentheses as needed. All right, so one thing I might notice is that 96 is fairly close to 100, and if I can just figure out, if I can kind of move some of the 57 over to the 96 to get 100, then that makes this addition problem a lot easier. So I would think, okay, well, what do I have to add to 96 to get 100? Well, I need a 4. All right, so what I want to do is just break down 57 into 4 plus something, and that something is 53. All right, so I've carefully chosen how to break this down in a way that makes it easier. And then next I want to move the parentheses around the 4 plus 96. And that's okay, I can make that change because this was all addition, it's all one operation, and so I have the associative property that says I can move the parentheses. And then from there we get 53 plus 100, or the answer, which is 153. Now, a common mistake here is to say back at this step that we used the associative property to rewrite 57 as 53 plus 4. Well, that actually doesn't have a property, it's just kind of breaking down the number. So associative property doesn't justify that. Associative property is used when you move parentheses. All right, so we used it to go from here to here. That's where we used it. And then same thing here, we don't have properties for the end, we're just working out the problem using order of operations. All right, here's another property, the distributive property. And this one is for multiplication over addition. So in order to use this, it has to be a number that's being multiplied by 2 numbers that are being added. And you've seen examples of this. Something like 3, we'll do a different example than the one that's given. 3 times 1 plus 5. And we distribute the 3, and we know that this equals 3 times 1 plus 3 times 5. Now a picture to explain why that's true. Okay, here's 3 times 2 plus 4. So basically we're thinking of this as 3 rows of 6, 3 rows of 2 plus 4. And the distributive property just says, okay, well I can rearrange and regroup here and instead look at the 3 groups of 2 first and look at the 3 groups of 4 and then add those together. Right? And visually you can see that we have the same number of yellow blocks on each side. So visually that shows that the answer is the same. The number of blocks is the answer. Okay. Now the difference in how you would work these two sides of the equation, in 3 times 2 plus 4, using order of operations, I would do the parentheses first to get 6. Then I would multiply by 3 to get 18. On the right, 3 plus 2 times 3 times 4, we would have parentheses first, 6 plus 12, and then we still end up with 18. Okay? And it's the distributive property that guarantees that that answer will always be the same. Okay, one use for this is breaking down problems and making them easier to compute mentally. So let's look at the problem 5 times 9. Now let's say that you were in elementary school and you don't know your 9 times tables yet. Well, there's a way around that. If you break 9 down into 6 plus 3, maybe you do know the 6 times tables and 3 times tables. Okay, and then the distributive property lets you do those 2 multiplications first before doing that addition. Okay, so same answer, just a different way to get there. All right, how about, let's try these 3 examples. 83 times 7, not easy to do mentally, but one option to break these down would be to break them down into the double-digit numbers, break them down into the tens place and the ones place. So I could make this 80 plus 3 instead of 83 times 7, and then I can distribute. All right. Now we didn't mention this, but you can distribute from either the right or the left. So here I'm distributing from the right-hand side, and this gives 80 times 7 plus 3 times 7. Okay. And then if you know your fact that 80 times 7 is the same as 8 times 7 plus a 0, that's 560 plus 21, and that's 581. Right, so perhaps that's easier to do mentally than trying to think about 83 times 7 in your head, or even writing this down like this and using that standard method, you know, where you multiply the ones, carry the tens, and then move on and do the tens. Okay, how about the next one? This one actually needs an extra property as well as the distributive property. All right, so notice we have this repeated 52, and I certainly don't want to multiply 19 times 52 and 52 times 14 in my head. So here's another option. If we switch this 52 and the 14, then I get 19 times 52 minus 14 times 52, and then once I have the 52 to the right of each of those numbers, I can use the distributive property kind of going backwards, so it's like I'm undistributing, and I'm going to take that out or factor that out, and then I'm left with 19 minus 14. All right, so this one is like going backwards. We had A times B minus, let's see, C times B, and then we're rewriting that as A minus C times B. Okay, and you can check if you go backwards, think about distributing the 52, and then you would see that you end up with this expression over here. Okay, and then that gives 19 minus 14 is 5. 5 times 52 All right, and perhaps that's a little bit easier to do in your head. Now I can do some different things with this. You maybe using the associative property, because I could rewrite 5 as 10 divided by 2, right, and go from there. Right. Or one option, let me just work this the same way that I did the last example. Okay, when you have a double-digit number like that, we can break that down. All right, so 5 times 52, I can make that 5 times 50 plus 2. And then that gives 5 times 50 and 5 times 2. So I use the distributive property again. And that's 250 plus 10, which is 260. Okay, so you may just be thinking, why are we doing this? Why can't I just use a calculator? It's a lot faster. And of course, that's true in this case. But the point is that these properties justify all of the arithmetic that we do and also give you some different options. So, maybe you don't prefer to use a calculator. Maybe you do like solving these problems mentally. Well, then this property gives you the flexibility to be able to do that. Okay, one other thing that I wanted to mention on that one. You may have noticed that we used the distributive property with subtraction. And we said that the distributive property was for multiplication over addition. So why are we allowed to use this property for subtraction? Well, the answer, if I had something like 3 times 2 minus 4, the answer is that I can just rewrite this as an addition problem. Instead of 2 minus 4, I can think of this as 2 plus negative 4, and now I do have multiplication over addition. So I'm still okay to use this on subtraction problems. Okay, and then finally, 7x plus 8x. You may remember from algebra that this is 15x. So you know the rule, combine like terms. Combine like terms. Now this is just an easy way to remember that we are using the distributive property for an algebraic expression. So here's the in-between step that explains why we can do this. Right? Notice that there's an x in each term here, each part. So what I can do is use that distributive property going backwards and factor that out. Then I can do order of operations. 7 plus 8 is 15, and then multiply by x. All right, so it's just one extra step in the middle there, and then using the distributive property to get to our answer. All right, we talked about the left and right distributive properties now. So you can distribute from the left or from the right, and then you can also use this property both ways. You can use it backwards, so I can say AB plus AC is the same as if I factor out an A. Okay, that's also the distributive property. Are there distributive properties for other operations? Right, well, one example in your homework that I'd like you to think about is this one. What about for exponents? Does A plus B squared equal A squared plus B squared? Is that a true statement? Can I distribute an exponent into parentheses? All right, what about, we did talk about subtraction, multiplication over subtraction, but I could come up with really any other example. I could do, I could switch these. I could do addition over multiplication. Is this the same thing as doing 3 plus 2 first and 3 plus 4 and then multiplying? All right, well, the first expression at the top, 3 is 3 plus 6, and that's 9. All right, this bottom one is 3 plus 2 is 5, and 3 plus 4 is 12, and 12 times 5 is 60, not 9. All right, so there is no distributive property for addition over multiplication. You can't switch them. I could do subtraction over division. 3 minus 5 divided by 1. Is that the same as 3 minus 5 divided by 3 minus 1? Okay, so try those out, decide if you think that those are equal or not. And then another question, does the distributive property work in other systems than real numbers? Well, here's one example of a system that does have the distributive property. You might remember matrix algebra if you had that in high school. Matrix algebra, or in another math course. All right. So if we had a matrix, which is just a kind of a grid of numbers, and let's say we're multiplying that times two other matrices. How about, we'll just keep going here, 5, 6, 7, 8 plus the matrix containing 9, 10, 11, 12. And it turns out that yes, we can distribute matrices and get the same answer. So we start learning these properties in the real numbers, but then we can go on and look at other systems. You may want to look at, even things like irrational numbers. Okay, does it work to distribute within the set of irrational numbers? And yeah, that one does work as well. All right, because those irrational numbers are a subset of the real numbers. Okay, we will stop there. So in this video we've talked about the commutative, associative, and distributive properties.